Hey everybody, welcome back to the Vintage Workshop. My name is Jeff. Today I am doing more metalworking. I have been rebuilding and manufacturing, machining more parts for my mudjacking business. I've got a bunch of parts that were worn out and I'm doing a complete rebuild on that machine over the winter, getting it ready. It's late February, middle February right now, and hopefully by next month we're going to be getting after it. So I'm replenishing my my parts rather than continually using the ones that are completely worn down. You can only weld them up and re-grind them and remachine them, etc. so many times before it's time to make new parts. So that's what I'm doing, and I'm going to take you guys along and show you. I had a couple of requests, which the channel's so small right now, I don't get many, so I've had quite a few guys ask me, hey, we'd love to see you machine some of those parts. So that's what I'm going to do. Yesterday, I ended up manufacturing one of the pumping tubes. This is the new one that I did yesterday. Unfortunately, I don't know what happened. The footage was terrible. It was all blurry, and this is an autofocus camera. So, and it's a relatively new one. It's a Canon 80D. So I don't know what happened, but anyway, we're gonna make more of these, so I'll show you exactly how I did it. But this is Schedule 80 pipe machined down to 5.5 inches and 10 thousandths of an inch, 5.010 inches. And a seal fits in there. And what rides inside here is a A-frame assembly. And here's one that I made several years ago that I ended up just repairing yesterday as well. And this is the pumping device. It's got a hydraulic piston that drives it back and forth. It opens. The mortar mix that we pump slides in there, and then it pushes forward with that plunger. And then there's a seal that wraps around here that rides and seals inside that tube that I just showed you. And that's how we get our pressure. It's a high pressure system. It's a 3,000 PSI hydraulic system. So we are making more parts for it. And one of the many bad parts that I need to make is the cover plate. This here is the rubber seal. It's neoprene rubber that is, it's got a high, I don't know what they call it, Duro number or something like that. It's like 75. Anyway, this gets compressed. This wraps around that A-frame like so. On there here, it slides right on. And then this plate is supposed to compress it. This plate was originally not machined by me. These are parts from 30 years ago. This one is made out of aluminum, and it has taken a serious ass whooping over the years and is just completely, it's like, it's just about had it. So I need to make another one of these. I do have another one that was made out of steel that I had a machinist make about 10 years ago, and it's fine except that the lip on it is too thick because I had these new seals just made here recently, and I had them cut to a thicker thickness. So if I compress this in too much, it ends up really tearing up the seal. Here's an example, and this is all trial and error because this is my machine. Here's a seal that's one of those ones. Well, you guys already saw the other one. It's just, this was only in the machine for 2 months and it's just completely destroyed. So I need to have them last a little longer than that. They're pretty expensive. So we're going to go ahead and machine a new plate. I'm going to take you guys over to the Racine Power Hacksaw. You guys saw me rebuild it and get that thing working good. And this is the reason why. I got a big hunk of 500 pounds of steel over there, 5.5 inch round. I've got to cut off about an 8.5 inch length, and then I'm going to cut that into smaller pieces. I'm not going to show you all that, but I'm going to take you over. We'll get this thing going. I'm going to time it. This is my big chance to see how fast this saw will actually cut that 5.5 inch round. And I've even got another one. I've got a whole pallet full of them, but I've got some 7-inch steel rounds as well that also need to be cut up for a different project, but we'll save that for another time. So let me take you over to the other side of the shop, and we'll get cutting. So here's my crazy setup. I've got the engine hoist rigged with a lift strap that is holding the center point of the big round. That's a 55 inch long, 5.5 inch diameter piece of steel. That's what we need to cut off. And you can see the part that's sticking out. I've already got the clamps all set up. And the hope is here that once I go ahead and finish the cut, that the whole thing doesn't go wonky on me, but we're going to have to just play that by ear because I need to get this thing going. So anyway, we will, I actually set it in there and I started releasing the tension on the hoist just to see, and the weight of that bar, literally, because it's sticking out so far out the back, started tipping over the saw. So I obviously didn't just let it go, but I went ahead and put the tension back on it. I need to build like an outrigger table for this, but for right now I'm just going to use this sucker to hold it up in the air, and we'll get busy making these parts. Still going, about halfway through. There we go. Oh, it's heavy. All right, did a nice job. I'm really happy with this saw. I tried to get a little smart during the cutting procedure, and I rigged up a sort of a half-assed outrigger there to hold the other end, just in case. It's a very heavy piece of steel. I'm going to have to look up and see what the weight is. Okay, we got that piece of 5-inch diameter steel chucked up over at the Monarch. It is dial indicated in, and we need to make several parts out of this piece. The first one we're going to make is the pressure plate. Cleaning off the rust on the first pass here. Four inches, 940 thousandths. We've got, to take this down to 4 inches, 540 thousandths, so we got 400 thousandths to come off. So let's get after it. Depth of cut's 150 thousandths. The diameter. 16,000. 67 thousandths more. As you can see, much nicer finish with the heavier cut, but in this particular instance, this thing is going to be submersed in mortar mix. I don't really care about the finish too much. Not hot at all. Big piece. $562, $561 and a half. So this is not an exact. So we got 22 thousandths to come off. Not a critical dimension. Alright, we got to punch a 2 1/4 inch hole through the center, but before we do that, I want to break the sharp edge there with a chamfering bit. Try not to get in your way here. Just using the center to get started. we don't have too far to go. This part is only a 1/2 inch thick, but I'm making several parts here, and every one of them is going to have a hole in them. So I'm going to go ahead and just drill out the center and do all those functions all at once to save time later. And then we'll part each piece off as we go. Okay. I don't have an internal chamfering tool, so I'll use my notebook just to break this edge. I'll cut my fingers up. I can get it better with sandpaper. Next up, we got to recess the face approximately 1/8 of an inch, and that's for compression on the rubber seal. It off. Get a chamfer while I got it like this. Breaking the edges, so I'm going to cut my fingers. A lot of smoke. Back on there. Sorry about the smoke, but I need it. I need the lube. Okay, we're down to the final setup here. I've got to go ahead and drill the 4 mounting holes. I've already taken the original plate that I'm replacing and used center punches to get the four locations for the new holes, and now I'm going to go ahead and use the Bridgeport just to drill those out. Spotting. Okay, rinse and repeat 3 more times. Alright gang, so we got the plate all done, and here it is installed on the A-frame. See if I can bring it in closer for you. You've got, it bolts in, and this is the rubber neoprene seal right here, and all of this gets compressed inside this cylinder right here. Like so. So we fit it in. That other end gets threaded on. I'm sure you guys can, I think you can see it. Here's the hydraulic cylinder already attached with polyurethane to its plate, and that's going to go in the back. This goes in the front. They get threaded together until they're mated to the right distance, and then once everything's together, I take a ratchet, I tighten the 4 bolts that go through, and that compresses the seal. And that seal is how we are able to pump the mortar mix that we pump at high rate of pressure. So I went ahead and I already made 1 extra. I've got a whole bunch of extras to make. Here's the worn out one. This thing is just chewed apart. Here's another A-frame assembly that is broke that I'm going to be machining more parts for. And then I am also going to be machining more new parts to make a couple of extra A-frame assemblies, because I'm also building another brand new hydraulic pump and for raising concrete, and I want to go ahead and have extra parts so that when this stuff breaks, because let me tell you, it always breaks, and when it does, you want to be able to get back in business as quickly as possible. So that I use the winter months for getting everything ready, so in the summer when one of these things breaks, if we hit a rock or anything gets in the material, then we are down for as little as possible. So that's going to be a wrap. So thanks again for tuning in. I hope you guys enjoyed this. I've got more to come. If you haven't already, please subscribe to my channel. It helps a lot in terms of getting noticed. And if you don't mind, if you like the video, please go ahead and hit that like button. I really enjoy the interaction with you guys down in the comments section, so if you have any questions or comments, please go ahead and leave them below. And I try to make sure I get, respond to every single one of them right now. The channel's small enough so it's easy to do that. So I appreciate it, and we'll see you guys real soon.